Okay, everyone, I'm just going to go ahead and walk through the pre-lab for you to either check your answers or to give you some help if you got stuck. So, number 1 says to write out the balanced chemical reaction of solid copper metal reacting with silver nitrate, and then produces copper 2 nitrate and pure silver. So what we're doing is we're translating the words into symbols. So copper is just Cu, okay? It's reacting with, so plus. Silver is Ag, nitrate is NO3 minus. Now silver always has a +1 charge, so they balance each other out, AgNO3. Okay, turning into copper 2 nitrate. So since copper has a -1 charge, the 2 is telling me the charge of copper. So the formula would be CuNO3 in parentheses with a 2 outside, and then pure silver, so just Ag. Okay, so there's the reaction with balanced charges. Now we do need to make sure that the overall reaction is balanced. So what I see here is that we have 2 nitrates on this side, so we're going to have 2 nitrates on the other side in order for that to be possible. So that means there should be a 2 in front of here. Sorry, I did not mean to do that in yellow. Okay, which means that 2 silvers would be produced. So now it's balanced and complete. Okay, our next question says, if 1.39 grams of copper react with a solution of 1.3 grams of silver nitrate to identify the limiting reactant. So what this question is asking is it wants to know which of the 2 are we going to run out of first, meaning once we run out of it, the reaction would stop. Now, the thing with limiting reactants is we have to look at them by the moles, because that's how reactions happen, is they happen, at the molecular level, atom by atom, molecule by molecule. So I'm going to take the grams they gave us, grams of copper, and I'm going to convert that into moles using the molar mass. So the molar mass of copper is 63.54 grams for every 1 mole of it. Okay, if I plug that in, we get 0.0219 moles of copper. Okay, let's find how many moles of silver nitrate we have. So AgNO3. Okay, silver nitrate has a molar mass of 169.87. Every 1 mole. I apologize for my writing, working on this pencil thing. And that gives us 0.00818 moles of Ag. Okay? Or silver nitrate, I should say. Now, we've got to look now at the ratio of what we have to the balanced equation. So in the balanced equation, we need twice the amount of silver nitrate that we do of copper. Well, if I look at the ratio here, first off, silver nitrate is less than the amount of copper, so it's definitely my limiting, because I'm not even close to just a 1-to-1 ratio, let alone I need a 2-to-1 ratio. So that tells me that for that particular situation, silver nitrate is my limiting reactant. Okay, the next one says, upon completion of the reaction, 0.75 grams of silver metal is actually produced. Determine the percent yield of silver metal using that percent yield equation. So the difference here is the actual is whatever we get in the lab. The theoretical is how much should have been able to be made based on the limiting reactant. So the first step we're going to do is to find the theoretical, is we're going to take our limiting reactant and figure out how much silver that should be able to make. So I'm going to take my limiting reactant, so, sorry about that, 0.00818 moles of AgNO3. And I'm going to find out how much silver that should make. So we know from the balanced equation that for every 2 moles of silver nitrate, it will make 2 moles of silver. So we have a 2 mole to AgNO3 for every 2 moles of Ag. Okay, then I'm going to convert it into grams. So for every 1 mole of Ag, silver has a molar mass of 107.87. Of Ag. Okay, I'm going to plug that in. And we find that we should be able to make, put it right here, 0.883 grams of Ag. So this number right here, that is my theoretical. It's how much, if everything went perfect, how much I should be able to make. Once again, the actual is whatever the lab gave us, which is a 0.75. So to find the percent yield, we're going to divide the 2 and times by 100. So I'm going to have let's change our color, 0.75 divided by 0.883 times by 100. Once again, this is still for just part B. I end up with an 84.9% yield. So what that tells me is I got 84% of what I should have been able to make based on the ingredients that I put in. Okay, the next one says calculate the amount of unreacted excess reagent that is left over upon completion of the reaction. So first off, our excess reactant is the opposite of our limiting reactant, so that would be our copper. So we know we used 1.39 grams originally, and not all of it got used up. So we want to know how much is left over upon completion. So the first step is we got to figure out, well, how much did get used, and then we could subtract it from how much we started with. So I know how much silver nitrate, because that's my limiting reactant, all of that is going to be used up. So I'm going to take my limiting reactant again. Whoops. I got a different pencil. There we go. Okay, so I'm taking my limiting reactant and I'm going to convert it into, oh, sorry, this is for part C. How much copper it needs to react with for a perfect ratio. So same thing, we're going to go to moles, which once again I could have started with moles here, but just going from the beginning. So 1 mole of AgNO3. Okay, for every 2 moles of AgNO3, it will need 1 mole of copper. And then every 1 mole of copper has a mass of 63.55. Okay, so let's plug that in. Okay, and we find that it is 0.26 grams of copper is what reacted. So to find what is left over, we just take our initials. We're going to take our 1.39 and subtract how much did react. And we find that in this reaction, we're going to have 5.35. Whoops, what am I doing? I looked at the wrong thing. 1.13. Grams that were left over. Okay, final problem is a particulate picture. It says complete a picture of the following reaction from the particulate view and identify the limiting reactant. So we just need to match up according to our balanced reaction. That 1 copper needs to react with 2 silver nitrates in order to make the product appropriately, because copper is going to pair up with nitrate, and then the silver comes out. And so I'm going to pair up here 1 copper for every 2 nitrates. So 1 copper for 2 nitrates. 1 copper for 2 nitrates. All right, I think I got them all. So we see that there should be 1 leftover copper here that didn't react. It's going to be in solid form. And then we're going to have copper nitrate. 1, 2, 3 of them. And then the silvers all get used up in terms of, we don't have any excess, but now they are just pure silver on their own. And so we should just have 5 of those. Like so. Hi everybody. So today we're doing a pretty simple experiment, but it has a pretty cool result in the end. I apologize once again that we can't do it in person, trying to make up some time, you know, because of COVID life. But hopefully you'll still be able to kind of see how it looks, and I'll show it to you actually in person next time on Friday, our results. But the reaction we're doing is we're going to react silver nitrate, which is in solution form. So I've dissolved some silver nitrate in some water to make our solution, and we're going to react it with copper. So pretty much the reaction is really simple, because I'm just going to stick this in there and let it react. So a few things, if you want to go to your data table here of our measurements. So the mass of our copper wire that I've measured out here is 3.74, is how many grams. So our copper wire has a mass of 3.74. And then the silver nitrate that we're using is, I have made 100 milliliters of a 0.5 molar solution. So we have 100 mils of 0.5 molarity solution. Yeah, and I'm just gonna put it together, and then I'll put my phone on it and we'll watch it go. Stay tuned. Bring it up so maybe you get a clearer view here. Now, the copper wire, right, is reacting with the silver nitrate in solution. So as our silver is forming, that's our beautiful little sparkly fuzz going on there. That's our actual silver that's being pulled out of the solution. The copper wire is getting covered, and so as it gets covered, it can't react anymore. So what I'm going to do now is I'm just going to stir it a little bit, knock off the silver, so that our copper is available to keep reacting. All right, let's keep watching. Okay, so I think you got enough of that, but pretty much I'm just going to let the reaction keep going, shaking it off, let it grow until it stops, meaning hopefully we've used up whatever one is our limiting reactant. And then once the reaction is complete, I'm going to pull the wire out, let it dry, weigh it, if there is any wire left, and get our silver out, let that dry, and weigh that as well. So when I get those measurements, I'll add them to our data table. Hi everybody, welcome back. Well, for you it hasn't been very long, but for me, I actually came home to finish this experiment, so welcome to my house. There's our Christmas tree. There's Juwan working on some shoes. Yeah, because, you know, I just have chemistry stuff at my house, so who doesn't do experiments in their kitchen, right? So, okay, so here's our reaction so far. Let me flip. Okay, so we got a good amount of silver there in the bottom. And now we're gonna put it through this filtration system. So I have a piece of filter paper in a funnel, so that can catch our silver, and then the solution will go through. It will also catch our copper, and then I'll pull the copper wire out and get a weight for it. Okay. I've got some silver chunks in there. I'm gonna put my phone down and scrape out, and then I'll come back once we get some weights. All right, there's our lovely clumpy silver here. So I just have some distilled water that I'm just gonna squirt it with to try to clean off any of the solution, as well as to clean off our wire so that when I weigh it, I don't take any of the silver with me. Because the goal is to keep as much silver as we possibly can. So let's take our copper wire and get a mass for it. Okay, so the mass of our copper wire, there it is, was 2.26 grams. So if we want to find out how much of the copper wire reacted, it started out as 3.74 minus our 2.26 to find how much did react. Now for the silver here, so it's all soggy itself, plus the paper is soggy. So to find our mass of our silver, we've got to let it dry. So I'm going to throw it in my oven and let it dry for a few minutes, and then we'll pull it out and get a mass. All right, and here is our beautiful silver. Look at that. So awesome. So I took the final weight of it with the paper, and it ended up. Okay, so our final measurement of the paper with the crystals was 5.48 grams. What I did instead is I just weighed the blank filter paper before, and so if we just subtract the two, we can figure out how much silver we made. And then from your answers, you should be able to do the various calculations that you need. Reach out if you need any help.